Okay, I want to talk about number systems. I'm not sure whether I'll include this in your exam or not. I thought I'd go ahead and talk to you a little bit about it. I probably won't, but I think that it needs explanation, so we'll take a few minutes to take a look at number systems. If I have a number, let's say 3,826, basically that fits in these place values: 3, 8, 2, and 6. And essentially what we would do is just multiply those. The 6 is in the ones place, the 2 is in the tens place, the 8's in the hundreds, and the 3's in the thousands place. So if I multiply 6 times 1, I get 6. If I multiply 2 times 10, I'll get 20. If I multiply 3 times 800, I get 800. And if I multiply 3 times 1,000, I get 3,000. And if I add those up, I will get the 3,826. Now what I want to look at is what happens if we have a different base. Let's suppose that I've got a base of 2. Now I'm going to look at a number and it's going to be 1, 1, 0, 1. Well, our place values are the same powers but just a different base. We're going to use base 2, so that would be 2 to the 0, 2 to the first, 2 to the second, and 2 to the third. Well, 2 to the 0 is 1. Anything raised to the 0 power is 1. 2 to the first is 2. 2 to the second is 4. 2 to the third is 8. If I want to go any farther, 2 to the fourth would be 16, 2 to the fifth would be 32, and so on out. Then I can simply add numbers. Okay, so let's take my number 1101. If I take 1, 1, 0, 1, and that's in base 2, and if I multiply those, what do I get? Well, 1 times 1 is 1, 2 times 0 is 0, 2 times 2 would be, that's going to be 0, 1 times 4 would be 4, and 1 times 8 would be 8. And what I'm going to do is add those, and I'm going to add in this direction. Okay, so 8 plus 4 is 12, plus 1 would be equal to 13, base 10. So our number 13 is written in base 2, 1101. Okay, so let's take another one here. Let's suppose that I've got 1011. Well, based on what I'm saying here is I've got a 1, I've got a 2, I've got a 0, and I've got an 8. Keep in mind, this is 2 to the 0, this is 2 to the first, this is 2 to the second, and this is 2 to the third. And if I add those, I don't have to do it diagonally like I did in the previous exercise. If I simply add those, that turns out to be 8, and 2 is 10, plus 1 would be 11. So 1011 is going to be 11. Okay, let's do a little exercise here. Let's just count by twos. Okay, let's go with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, 1 would be simply 0, 0, 0, 1. I get 2 to the 0. This would be 0, 0, 1, 0, because I get no ones, but I get a 2 to the first power. And maybe I should move that down here and make sure that we understand that what we're looking at is this is 2 to the third, this is 2 to the second, this is 2 to the first, and this is 2 to the 0. And again, 2 to the 0 is 1, so that 1 would be 2 to the 0, and I don't get anything else. 2 would be this place right here. Okay, so what's 3 going to be? Well, 3 would be a 2, which is right here, and a 1. 2 plus 1 would be 3. Where's 4? Well, it's in this column right here. This is 4, so it's going to be, I don't get a 2 to the third. I do get a 2 to the second. I don't get a 2 to the first. I don't get a 2 to the 0. Where's 5? Well, 5 should be 4 plus 1, so it should be 0, 1, 0, 1. Let's look at 6. What's 6? Well, it's not going to have a 2 to the 3. I can't have an 8. I can have a 4, and I can have a 2, but I don't need a 1. Okay, so that's going to be 4 plus 2. The 7 is going to be the 6 plus 1 more. What's the 8? Well, it's going to be the 8 and nothing else. What's 9? Well, it's going to be 8 plus a 1. What's 10? Well, it's going to be 8 plus 2. This is going to be 8 plus 1. This will be 6 plus 1. Now hopefully that makes sense to you. Okay, let's look at one more. Let's look at hexadecimal. Now what I want to do is set up a correspondence between the hexadecimal and the decimal. And basically, hexadecimal, we're going to start with 0. 0 corresponds with 0. 1 corresponds with 1. 2 corresponds with 2. 3 corresponds with 3. 4 corresponds with 4. 5 with 5. 6 with 6. 7 corresponds with 7. 8 corresponds with 8. 9 with 9. And here's where it begins to get different. 10 corresponds with A. 11 corresponds with B. 12 corresponds with C. 13 with D. 14 with E. And 15 with F. Now that should give us 16 digits in the hexadecimal, which is what we want. Okay, now let's take a look at how this works. Suppose that I have a number, I don't know, 1DF, base 16, and I want to know what the equivalent decimal is. Well, keep in mind that these are powers of 16. Well, 16 to the first, 16 to the 0 is 1. 16 to the first is 16. And 16 squared is 256. So that means I have 1, D. D is what? D is 13, so that would be 13 here. And F is what? F is 15. So if I multiply 256 times 1, I'll get 256. If I take 13 times 16, 13 times 16, that's 208. And 15 times 1 is 15. So now what I would do is simply add those numbers up. So if I take 256 plus 208 plus 15, I will get 465. And I'm going to check my arithmetic if you don't mind, because I have a tendency to make mistakes. The important aspect here is make sure that your arithmetic is right. Okay, it's 479, not the 465 that I originally had. So 1DF base 16 right here is 479 base 10. Okay, now let's go the other way. Let's take that 479 and see if we can figure out a way to get to the decimal. And basically it's simply division and looking at remainders. Now I want 479 base 10, and I want to figure out how do I get to base 16. That's what I'm interested in. Well, bottom line is you simply take 16 into 479. Now on your calculator, what you can do okay, if I take 479 and divide it by 16, I will get 29 point 9375. Okay, basically what I'm interested in is what's this remainder here is all I want to know. That's the only thing that I want is this piece right here. What is the remainder? Okay, a couple of ways you can do it. You can take 16 times 0.9375 and that will give you the remainder. So let's see what it says. What is 16 times 9375? Well, 0.9375 times 16 turns out to be 15. So that means that I have a remainder here of 15. Another way you can do it, if you want to, you can take 29 times 16 which is 464, and the 464 goes right here, and subtract. Okay, that's all you have to do, get that remainder. So I want one remainder there. Okay, the next step is to take 29 and divide it by 16. And once again, the only thing that I'm interested in is this remainder right here. Well, it looks like it goes one time. With a remainder of 13. And again, there's my remainder. Now, if you need a calculator, obviously you can do that. You can use the same process that I did here, but you don't have to. Okay, so I got one remainder, two remainders. Then I want to take this thing right here, just like I took the 29. I want to take the 1. So I want 16 goes into 1. How many times will 16 go into 1? It'll go 0. Well, that's what we want. This is where I want to stop, is whenever I get to 0. And I have a remainder of 1. There's the next remainder. Okay, now those remainders 1, 15, oops, I'm sorry, 13 next, and then 15. Keep them in the order just like you found them here. 1, 13, 15. 1 corresponds with 1. 13 corresponds with D, and 15 corresponds with F. So our number 1DF base 16 is the 479 that we started with, which we already knew. Okay, so up here in this example, what we did was we took 1DF and converted it to 479. Multiplying 1 times 256, 13 times 16, and 15 times 1. We got the 13 from the D and the 15 from the F. On this example down here, what I took was the 479 and I want to convert it to a hexadecimal, and I just simply did the long division. The long division, and the only thing that I'm interested in are the remainders. And you continue until you get a remainder of 0, and then you list these 1, 13, 15. Pick up your symbols from our corresponding group here, our corresponding digits, and it's 1DF6 base 16. What would 479 be base 2? Now I'm going to use the same process that I did up here, except that because 2 is so small, what I'm going to go ahead and look at are the powers of 2. 2 to the first, 2 to the 0, 2 to the first, 2 to the second, 2 to the third, 2 to the fourth. What are these numbers? Well, that's 1, that's 2, that's 4, that's 8, that's 16. 2 to the fifth would be 32. 2 to the sixth would be 64. 2 to the seventh is 64 times 2, that's 128. 2 to the eighth is 256. And 2 to the ninth is 2 times 256, which is 12, 10, 11, 512. Now, I want you to notice that 512 is bigger than my 479, so I'm going to start with 2 to the 8th. Now, what that means is that I'm going to have 8 digits here. 1, 2, 3, 4, 5, 6, 7, 8 digits to represent this number right here. This is base 10. This is what you normally see. Okay, so we're going to take just like we did previously, but I'm going to start with 256. The biggest value that will go into the 479. 479 divided by 256. Well, how many times will it go? Well, I don't know. Let's go see. What is 479 divided by 256? And that is 1 with a remainder. Okay, so that means that I'm going to have, this is 0, 1, 2, 3, 4, 5, 6, 7. I need one more. 8. What's my remainder? What is 256 times 1? Well, that's 256. So if I subtract those, that's 3, that's 2, and that's 2. Well, I need now to divide 223. Well, 256 won't go in, so we're going to use 2 to the 7th. We're going to divide that by 128. And it goes one time. And if I subtract, I get 95. So I got 95 divided by what? Looks like this one right here, 64. Goes one time, so I get a 64 over here. And if I subtract, I'll get what? 31. All right. Well, that one won't work. I don't get this one. So that's going to be a 0 because that won't divide. What's 31? What's the next one? Well, 16 divides it, right? And it goes one time. There's my 16. It looks like I got a remainder of about 15. Okay, so now I want 15 divided by 8. Picked an odd number, so I want to get an 8. And that's a remainder of 7. So I'm going to take 7. Does it divide by 4? Yep. Whew, this is a tough one. So I got a 4. Alright, how about 3? 3 divides by 2. So I get a 2. And I have a remainder of 1. So 439 is this digit right here. Keep in mind, this is 2 to the 0, 2 to the 1st, 2 to the 2nd, 2 to the 3rd, 2 to the 4th, 2 to the 5th, 6, 7, 8. One more. Let me see if I can pick a smaller number instead of using that big one. And I'm going to go out to the side here so we can see what we're doing here. Let's just take a smaller number. Let's take 98 base 10, and I want to convert it to base 2, whatever it happens to be. Well, what's the biggest power of 10, or excuse me, biggest power of 2 that will divide it into 98? 64. Looks like it's this one right here. Okay, 2 to the 6 will divide it, so I'm going to have 2 to the 6th, 2 to the 5th, 2 to the 4th, 2 to the 3rd, 2 to the 2nd, 2 to the 1st, 2 to the 0. I've got 1, 2, 3, 4, 5, 6, 7 powers. Okay? Alright, so now the question is how many times will 64 go into 98? Well, it better only go one time. So I get a 2 to the 6 right there. What's the remainder? The remainder is 34. I want to divide it. What's the biggest number that will divide into it? Well, 32. So I'm going to have a... And I'm going to put my powers down here. This is... This is 2 to the 0, 2 to the 1st, 2 to the 2nd, 2 to the 3rd, 2 to the 4th, 2 to the 5th, 2 to the 6th. Okay, now we've already got the 5th. The 5th is 32. How many times will 32 go into 34? One time with a remainder of 2. So now I want to divide the 2. Well, 2 to the 4th won't go into it, so I'll get a 0 there. 2 to the 3rd won't go into it, so I'll get a 0 there. 2 squared won't go into it, so I'll get a 0 there. 2 to the 1st, 2 to the 1st will go. With a remainder of 0, well, I don't get any more then, do I? So 98 is 11000010. Even numbers will always end in a 0, because that's either going to be 1 or nothing. Look at your pattern. 2, 1, 2, 3, 4, 5, 6, 7, 8. One, 2, 3, 4, 5, 6, 7, and 8. And that pattern is going to continue on. A 9 would be an 8 plus a 1. Okay. I don't know how much of this you're going to have in advanced topics. You've got hexadecimal is how you represent computer programming languages, but basically the computer sees ones and zeros because it's either a switch is either on or it's off. If I can find it, I'll show you how a computer adds two numbers, just for your information. I won't test you on that. And again, this is just an explanation. Take a look at it. I'm not sure whether I want to include it in your test or not. I probably will not. I'll let you know at test time. Don't spend a whole lot of time on number systems. Alrighty.